This video is on the objective graph a circle or a line from a polar equation. All right. And this is the second video related to this objective that I'm doing. I'm hoping you watched the first one, because I said in the first one the name of this objective is deceiving. Because in the first video, one of the questions you might come across where I think I had to graph r equals 5 times the sine of 4 theta. And that polar equation, the graph of that equation wasn't a circle or a line. There was something called a rose, right, with 8 petals and stuff, right? So again, hopefully you saw the first video. But what I hope to get at is how do we graph polar equations? And you can graph polar equations in a similar fashion to how you would graph rectangular equations in x and y. Right, remember, for rectangular equations with x's and y's, you start making a table, picking values for x, finding values for y, and then plotting those points. Well, you can do the same for these polar equations. Make a chart with r's and thetas, and pick values of theta, and get values of r, or pick values of r, get values of theta. And then every time you have a new pair, you plot those points. So let's take a look at a much simpler one. Now this one will actually tie into the name of the objective, right? Graph a circle or a line from a polar equation. And if you want to see more about the objective, of course, click on More Instruction and look at their videos, their notes, their examples. Alright, so here we're given the equation, theta equals 5 pi over 12. Alright, theta equals 5 pi over 12. Alright, so I'll go to a piece of paper. We'll talk about how to graph something like this on the polar grid. Right, so I'm going to make a very rough polar grid. So you have a vertical axis, right, horizontal axis. The horizontal axis is our polar axis. Right? The vertical axis means nothing. It's just to mark off every quadrant. And I'll mark off some numbers on the polar axis here. 1, 2, 3, 4. And on the vertical axis, why not? And remember how we're traveling on the polar grid, right? When you give a location in r and theta, you're traveling on circles that are centered at the origin, right? You're not traveling on rectangles. So there's a circle of radius 1. Here's a circle of radius 2. A circle of radius 3, and so on, right? Just making a very quick, hand drawing of a polar grid here. It's not great, but does the job. And we're asked to graph this. Theta equals 5 pi over 12. Okay, so now if you want, you could change that to degrees. Just make sure you know how many degrees things is. Pi, I think pi over 12. Alright, that's 15 degrees. Right, 12 times 15 is 180. And then this is 5 of those. So this is 75 degrees, right, if you're doing degrees. Now if you were to make a table, I'll make a little table here with r's and thetas. So this is separate from the graph here. Well, what this is telling me is that no matter what r is, theta has to be 5 pi over 12. Right, so theta is always going to be 5 pi over 12. Okay, so whether r is 0 or 1 or -1 or 2 or -2 or whatever, the value of theta is going to be 5 pi over 12. All right, so let's take a look at, pardon me, where those points are. Remember how to plot points. Now remember, we're doing ordered pairs like this. It's r comma theta. Well, anytime r is 0, you are at the pole. So that's this point here. There's the point 0 comma 5 pi over 12. It's at the pole. Now what about 1 5 pi over 12? So I go to 1 on the polar axis and then travel on the circle with a radius of 1. I travel from here 5 pi over 12, which is 75 degrees. And I'm doing a positive angle, so it's counterclockwise. So I'll end up here somewhere, right? There's about 75 degrees counterclockwise on that circle. So here's the point 1 comma 5 pi over 12. How about -1 5 pi over 12? So I go to -1, right, so start over here. I go to -1 on the polar axis and then travel, 5 pi over 12, 75 degrees in the counterclockwise direction on this circle. So that's about here. Right, here's -1 5 pi over 12. And you may notice something already. These points seem to be, falling in a straight line that, go through the origin. And we'll see that that is indeed the case. How about this? 2 5 pi over 12. So I go to 2 on the polar axis and then travel on this circle, 5 pi over 12 in the counterclockwise direction. So that's landing me here. -2 5 pi over 12. So I go to -2 on the polar axis and travel counterclockwise pi over 12, 75 degrees. That lands me here. And look, indeed, this is happening. This is all of these points. It's a line. It's a line going through the origin. And that's the case for any theta equals some constant. Right? If you have a graph of theta equals some constant, the graph will be just a line going through the origin. So it'll be just a line through the origin where the angle off the horizontal is whatever c is. Right? This angle is 5 pi over 12. So this is the general graph of theta equals some constant. It is a line through the origin. Now, we could have also done this. Right? We could have also done this. Some equations are easy to change. Right? Some equations are easy to change into rectangular coordinates. Theta equals 5 pi over 12. You can try to convert. Now, not all equations. You don't have to do this. I'm just saying you could try this, or try to change it to its rectangular version. So if I take the tangent of both sides, right? Let's take the tangent of both sides. The tangent of theta would be equal to the tangent of 5 pi over 12, which this isn't a nice number. Now I could use the tangent of a sum formula to figure this out, but I'm just going to punch this in a calculator. And when I convert to rectangular, remember the tangent of theta is just y over x. So y over x equals the tangent of 5 pi over 12. And then solving for y here, we get y equals the tangent of 5 pi over 12 times x. And this, because 5 pi over 12 is only 75 degrees, this is some positive number. So I know that we have y equals, some positive number times x. This is the equation of a line with this slope, right? The slope being the tangent of 5 pi over 12, whatever that is. It's a line with a positive slope going through the origin, which is exactly what I'm seeing in my graph up here, right? This is a line with a positive slope going through the origin. And if you want to verify that this truly is the graph, let's have a calculator do this for us. Now I'm going to go to a online graphing calculator called Desmos. This is desmos.com, free online graphing calculator. And the beautiful thing about this is if you type an equation with x and y, it'll graph things in rectangular. If you type an equation with r's and thetas, it'll graph it in polar on the same plane. It's very nice. So we have the equation theta. Now you can just type out the word theta and it changes it to the symbol theta. Theta equals 5, and then the same thing for pi. You just type pi, it changes it to the pi symbol. 5 pi over 12. Ooh, okay. Why is that not graphing? Why can't I graph theta as a function of anything yet? Ah, okay, so it looks like there's some limit to this. Looks like you have to have r equals. You have to have r in this. Like if I put r in here, maybe. Yeah, if I had r equals some number, it would work, right? R equals 3. Yeah, okay. So I guess you can't. Alright, I apologize. Looks like this is limited. But let me type in that rectangular equation. Y equals the tangent of 5 pi over 12 times x. And there's that line. Okay, this is the rectangular version of that equation. But you see it as a line with a positive slope going through the origin, like I said, right? Like I had here. Right. Yeah, so I mean you can't graph it on Desmos, unfortunately. Theta equals whatever, but it's an easy one, right? Theta equals a constant will be a line through the origin. Very simple. And then they have you, picking the correct one down here, not that one. Yeah, remember this is about 75 degrees off the horizontal. Looks like that one. Yeah, that's the only one that looks like what I had. Wonderful. Alright, and hopefully watching me go through this, reading the more instruction when necessary, looking at the answer explanations when they come up. I'm hoping all this stuff helps you out when you go about doing this on your own. All right, thank you very much for watching.